All right, question 6.6. The weight of tomatoes chosen at random from a bin at the farmer's market follows a normal distribution with mean 10 ounces and standard deviation 1 ounce. Suppose we pick 4 tomatoes at random from the bin and find their total weight. The random variable t is, and then we have 5 choices. Okay, so let's define a couple different variables. So I'm going to say x1 is the weight of the first tomato. X2 will be the weight of the second tomato. X3 will be the weight of the third tomato. And X4 will be the weight of the fourth tomato. Okay, so I have 4 random variables because each tomato is going to have a different weight, and that weight is going to be random. Okay. Now, it's going to be true, though, that for each of those random variables, the mean will be 10 ounces and the standard deviation will be 1 ounce. Okay. So the mean of x1 will be 10, and the standard deviation of x1 will be 1. The mean of x2 will be 10, the standard deviation of x2 will be 1, and so on. Right. The reason why they all have the same mean and standard deviation is because they all come from the same population of tomatoes. Okay. All right, so now the last variable, t, is the total weight. Okay, so that means t is equal to the sum of x1 plus x2 plus x3 plus x4. All right, so when we combine variables, the mean for the total is just the sum of the individual means. In other words, the mean for the total weight is going to be the mean from x1 plus the mean from x2 plus the mean from x3 plus the mean from x4. And all of those means happen to be 10, so it's just 10 plus 10 plus 10 plus 10 plus 10. I don't know how many times I said 10. Hopefully I just said it 4 times. All right, so it'll be 40 ounces. Yeah. OZ. All right, so that's the mean for the total weight. Now for the standard deviation, okay, so unfortunately there's not a direct way to calculate the standard deviation. We can calculate the variance though. Okay. So it turns out that the variance of the total weight is the sum of the variances from each of the 4 variables that we added. So it's the variance from x1 plus the variance from x2 plus the variance from x3 plus the variance from x4. Okay. Now we don't, well, I mean, we do know, but we weren't directly told the variance of each of those variables, but then we know the standard deviation is 1. And to go from standard deviation to variance, you just square. So the variance is 1 squared, which is still 1. So I'll write it as 1 squared plus 1 squared plus 1 squared plus 1 squared, which in the end is just going to be 1 plus 1 plus 1 plus 1, or 4 ounces. Okay. That's the variance though. Okay. All the answer choices don't mention variance, they mention standard deviation. So how do we convert back? Well, if squaring got us from the standard deviation to the variance, then square rooting will get us from the variance back to the standard deviation. So the standard deviation of t is going to be the square root of 4 ounces, which is just 2 ounces. Okay. All right, so with that, we can probably eliminate some answer choice. Like we could have eliminated choice A right from the get-go because the mean is not 10 ounces. And then now we could eliminate, which one? We could eliminate C and E because the standard deviation is not 4 ounces. Okay, so all that's left is B and D. The only difference between those two choices is the shape of the distribution. B says the shape for T is normal, and D says the shape for T is binomial. Well, so what sort of shape did we start with? We started with a shape of a distribution of tomatoes that was normally distributed. So if the population was normal, then the sum of these random variables should be normal as well. It's very strange to start with something normal and then end up with something binomial. That doesn't make a lot of sense. So the answer is going to be